Statistics, Modeling, and Finance, Chapter 4, Inferential Statistics, page 23, Multiple Regression.
Multiple regression. We said that linear regression looks at whether two variables have a linear relationship. For example, we investigated the relationship between square foot size and value in residences. Linear regression relationships can be examined on a two-dimensional graph. Multiple regression relationships must be examined through the use of an equation. In the contrived example we studied, we concluded that size accounted for 88% of the value. But what about the rest? Other value factors could include age, condition, quality, lot size, number of bedrooms, basement or not, patios and decks. With multiple regression, we can study the relationships of one dependent variable with multiple independent variables. Multiple regression analysis is defined as a technique for analyzing the relationship between one dependent outcome variable and more than one independent explanatory or predictor variable. The formula for multiple regression analysis is a variation on the linear regression formula. It is y equals b0 plus b1 x1 plus b2 x2 plus bn xn plus e. Y equals value, the dependent variable. b0 equals the y-intercept. b1 to bn equals the coefficients, slopes. x1 to xn equals the independent variables. E equals random error, the residual that is unexplained. It is similar to the linear regression, but is expanded. The symbol b0 is used instead of a, but it amounts to the same thing. It represents a constant, where the line crosses the y-axis. Then we add the product of each of the independent variables multiplied by the coefficient, b times x. There may be 2, 3, 10 or 30 variables. The last item, e, is the amount of error that will still be left after our best efforts. It is unlikely that we will be able to account for 100% of the factors that influence value. End of page. Error and independent variables. Error is defined as, in statistics, the unexplained or random aspect of a relationship among variables. Random error occurs when a relationship is not deterministic. Sampling error is defined as the difference between a sample statistic and the true population parameter. Independent variables. In one example, we had size in square feet as an independent variable. So, we entered numbers like 1,214 and 1,158. In another example, we had prices per acre, and we dealt with numbers such as $32,789. Other variables might be something that is either present or not. For instance, does the property have a patio or not? Here we will substitute ordinals for yes or no. If a patio is present, we enter 1, and if there is none, we enter 0. Other examples would be to use such a ranking system for whether or not a property has a fireplace, swimming pool or basement. In some cases, we may use scales to represent relative measures. The number 5 may be used for excellent, 4 for good, 3 for average, 2 for fair, and 1 for poor. An ordinal variable is defined as a categorical variable indicating rank order, such as small, medium, and large. Contrasts with nominal categorical variables, which do not indicate rank order. An example of this might be rating property condition based on a scale of 1 through 5. This type of variable provides more information than nominal data, although it is more limited than interval or ratio variables since the rankings themselves do not provide any information concerning the distance between each ranking. In other words, a ranking variable for condition does not imply that a score of 4 is twice as good as a score of 2. The correct interpretation would be that the score of 4 is 2 levels above the score of 2. End of page.